I want to talk a little bit more about the normal large sample condition, particularly the situation in number 3 where the population shape is unknown and our sample size is less than 30. And I said we have to look at the distribution of the sample, draw a graph, and if there is no obvious skew or no extreme outliers, then it's okay to use the t-model. Okay, the t-model obviously has a shape like a normal model, so it's basically kind of similar to the normal model but for smaller samples. But what happens when we take small samples from a normally distributed population? So we're going to do a little calculator sampling here. So what I did was I created a list called normal sample. That's my list name. And I did this command on the calculator, random norm, which simulates taking a sample of data from a normally distributed population, in this case with a mean of 100 and a standard deviation of 15, and I took a large sample of 500, and I stored it to the list, and then I used this list, so I'll show you what the list looks like. So it stored these data values into the list, 100 different or 500 of them, and then I made a dot plot of the data. So here's a dot plot. So even 500 from a normally distributed population doesn't look exactly normal, it just looks approximately normal. So you can imagine that small samples might not look as normal, even as approximately normal as this. So here's a dot plot. I'm going to go to the menu, plot type, change this to a histogram. Okay, so you can see it's not perfectly normal, but it's approximately normal. I also want to show you something called a normal probability plot. So in a normal probability plot, what this does is takes the sample values and takes their z-scores. So basically, here's our sample values. And then we make the z-scores, x minus, this is the mean of my sample and the standard deviation of my sample. Notice they're both really close to 115, which is for the population. And so these are all, then the y's are the expected z-scores that I get from, if all of my data came from a normal model, and I take the z-scores, and they all are close to this line. The line is basically what I would get if every single value from my sample came from exactly from a normally distributed population. And so the closer the points are to the line, the more I can say that the original population was a normal model. This is particularly helpful when I have really small samples that don't make really very nice histograms or dot plots for me to look at. So I've done this now with a large sample, and I want to now see how this works with a smaller sample. So I'm just going to create another I'll just call this norm sample. A norm samp, because I want to just take small samples now for size, maybe 20 or something. So let's take a look. So I'm going to do the same thing as I had up here, only I'm going to send it to norm samp, and I'm going to do a smaller sample. So let's just do a sample of size 20, for example. Okay, so now I want to make a graph of my norm samp here. This is because I have 500 data values in the calculator, so norm samp. Okay. All right. Now, does that look like a normal model? Not really. It just kind of looks like a bunch of dots. But I know that these came from a normally distributed population because that's what I simulated them to be. So let's try some other plot types to see what it looks like. There's a histogram. I could make the bars a different size, but I'm seeing kind of a reasonably normal looking shape. I want to also try a normal probability plot. Okay, fairly linear. So how do I check that my data came from a normally distributed population? So let me go back to the original dot plot here that I had. All I have to do is look at this and say, I don't see any extreme skew, I don't see any extreme outliers. It's reasonable to assume that this could have come from a normally distributed population. That's all I have to do to verify that condition. So let's do another one. Okay. So now if I go back to my data here, and I'll just zoom data, it will kind of change. Okay, there's another sample. Okay, that one actually looks a little bit more like it did kind of like a normal distribution. Let's go back to what I did before, and this time I want to do just a sample of size 10. Okay, so let's say I have a sample of size 10. Okay. You know, I'm going to have to look and see if I need to clear out some values down below here. Okay, nope, that's good. I thought maybe there might be some little zeros in here from previous spots being held. Okay, so I'm going to go to my graph now. Okay, now when I look at this, I say, that doesn't look like much of anything at all. If I were to make a histogram out of this, plot type histogram, okay, you know, it does look kind of like it has an outlier, although probably it would make more sense to make the bars to be wider. It takes a while to go through all this, though, with plot properties, and then I go to histogram properties, and I go bin settings, equal bin width. Let's make them 10 instead of 5. Let's just try that. Okay, and then I can kind of do a zoom data here. Okay, when I look at this, I'm thinking, oh, that kind of bothers me. I got this sort of outlier out here, and this. It turns out that a distribution of data from a normal population, if it's small enough, might not look very normal at all. So that's why this you can't be too picky about how it looks. It's not going to ever look perfectly normally distributed. I just have to say, is it reasonable that this could have come from a normal distribution? So that's why I'm showing you several samples. Okay, let's do another sample of size 10, just to show you what they might look like. So if I go back to here, okay, now that one actually does look more like a normal distribution. I'm going to go back to a dot plot. Okay, see. All right, does it look, you know, they're kind of clustered in the middle with a few here and a few here. If I do a normal probability plot, does it look reasonably straight? Okay, these are the kind of things you're going to look for to verify that condition. And when you do this, you have to draw the graph. Just recognize that you might get something that doesn't look completely like a normal model when it's a small sample, but it still could plausibly have come from a normally distributed population, because all of these samples do come from a normally distributed population. So that's my little kind of a extra help on this one condition that I wanted to show you.